Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In the previous class, we learned the ionic bond formation and what are the energy factors which are involved in the ionic bond. Now, in this class, we are going to study a very interesting and important theory that is called valence bond theory. We also called VBT, and it is explain the stability of hydrogen bonding, that is covalent bonding in hydrogen molecule. Valence bond theory, that is simply called VBT. This valence bond theory is proposed by the scientists Hitler and London in the year of 1927. It was proposed by the scientists Hitler and London in the year of 1927 to explain the stability of hydrogen bonded molecule. Later, it was extended by Salter and Pauling to explain the stability of hydrogen bonding in hydrogen molecule. Later, this theory is extended by the scientists Salter and Pauling. So let us assume to understand the valence bond theory in hydrogen molecule. Here there are two hydrogen atoms, H2, that can be written like H mod H. Let us assume the first hydrogen atom is A and the second hydrogen atom is B. Okay. Now to understand the valence bond theory, let's consider two hydrogen atoms, the hydrogen atom A and hydrogen atom B. That is the hydrogen atom A and the hydrogen atom B. Now the hydrogen atom A having nucleus, all atoms having nucleus, inside that there is a protons and neutrons. This is called nucleus. Let's take here. For the hydrogen atom A, the nucleus we are taking Na. And similarly the second hydrogen atom also having nucleus, that atom represented N. The nucleus is represented here. This one also having protons and neutrons. Nucleus means that containing protons and neutrons, right? So that one considered as Nb. Means nucleus of an atom B is considered as Nb. And around that means around the nucleus there is a definite orbitals, right? Like that. Orbitals. For this hydrogen atom having only one orbit, that is 1s 1 shell, and having only one electron, that is electron 1. Okay, so that electron is called as a He for atom A, and similarly for atom B, He. Okay, got it? Let's assume two hydrogen atom A and B. The nucleus of an atom is Na and nucleus of an atom B Nb. Then electron of an atom A is called Ea and electron of an atom is He. If these two are very close to each other, then the covalent bond is formed. Before that, if two atoms are away from one another, the energy of an atom is zero, and there is no any attractive or repulsive force between the atoms. At that time, the atom energy is zero, that is E is equal to zero energy, but there is only attractive force between nucleus of an atom and electron of that atom only. Okay, this is the concept of an atom, means one single atom before they are come to close to each other. Now these two atoms are come to close each other and nearer to one another. The repulsive force and attractive force is operate between these two atoms. Because you know equal charges or same charges is repel each other and opposite charges is attract each other. These are the same charges, either it will be plus and minus, or same charges minus and minus or plus and plus. These two are repel each other, and the opposite charges, that is plus minus or minus plus, these two are attract each other. You know, in an atom, the nucleus is positively charged one and electron is negatively charged one. When atom is single, the attractive force is present between the nucleus and electron of a same atom. During that case, the energy of an atom is zero. Got it? If these two atoms come to close each other, nearer to each other, then the repulsive force is operate between these two electrons and these two nucleuses, right? And similarly, the attractive force is also operate between electron of one atom and nucleus of another atom. Then electron of the second atom and nucleus of a first atom, because these two are what? Opposite charges. That is operate between these two nucleus or these two atoms. During that time, the covalent bond is formed. That was explained by in valence bond theory, the scientists Salter and Pauling and also Hitler and London. Now observe what are the forces. Repulsive forces and attractive forces are present between these two atoms. Here, the repulsive force or attractive force. The attractive force is operated between nucleus of an atom in A and electron of an atom B. So between these two, the attractive force is operate because nucleus is positively charged, electron is negatively charged. And also electron of B or nucleus of B to electron of A. Between these two, attractive force is operate. Attractive force. Similarly, the repulsive force is operate between electron of atom A and electron of atom B. That is EA and EB. Then similarly, nucleus of an atom A and nucleus of an atom B. Between these two, repulsive force is operated. Repulsive force. Now, both the atoms have come to close each other. At that time, both opposite attractive force and repulsive force is moderate. During that time, the atom is stable and having least energy. ಅಂದ್ರೆ ಎರಡು ಆಟಮು ಒಂದಕ್ಕೊಂದು ಹತ್ರ ಬಂದಾಗ ಸ್ವಲ್ಪ ದೂರ ಇದ್ದಾಗ ಏನಾಗುತ್ತದೆ, ಎರಡು ಮಧ್ಯೆ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ. ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್, ಇಫ್ two atoms are bit far to each other, the repulsive force is more and attractive force is less. If those two are coming nearer to another at a certain distance, both attractive force and repulsive force is balanced. During that time, both the hydrogen atom form a covalent bond. Okay, at that time the energy E is less energy, means energy is less and form covalent bond and molecule become stable. When energy is less, then molecule becomes stable. Okay, that you get the covalent bond. And the distance between the nucleus of one atom to nucleus of another atom, that is called covalent bond. Covalent bond are also called as length of bond, are also called bond length. Okay, this one having minimum energy, means least energy or less energy. Okay, this is the concept of formation of covalent bond between two hydrogen atoms. Got it? Now we are going to study the formation of covalent bond by overlapping of orbitals, that is orbital overlapping concept. The next concept is orbital overlapping concepts. You know, in valence bond theory, how the hydrogen molecule is formed. Okay, when two hydrogen atoms comes to close to each other, at that time the minimum energy is present between the two atoms. They form a covalent bond. Okay, during that time the orbitals of one hydrogen atom is overlapped with the orbital of another hydrogen atom. Similarly, in overlapping concept means orbital overlapping concept, the orbitals of an atom of valence shell orbitals having single electrons or unpaired electrons, they get start to overlap each other and form a covalent bond. That is explained under the concept of orbital overlapping. Here the orbitals are overlapped in three ways. That is positive overlapping and positive negative orbitals overlapping or neutral overlapping of orbitals. ಓಕೆ ಗಾಟ್ ಇಟ್. ಅಂದ್ರೆ ಎರಡು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಆಗಿ ಟೂ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ಆಗಿ ಫಾರ್ಮ್ ಆದಾಗ H2 ಬಾಂಡ್ ಆಗಿ H2 ಮಾಲಿಕ್ಯೂಲ್ ಆಗಿ ಫಾರ್ಮ್ ಆದಾಗ ಈ ಎರಡು ಆಟಮ್ಸ್ ಒಂದಕ್ಕೊಂದು ಹತ್ರ ಬಂದಿರುತ್ತೆ. ಹತ್ರ ಬಂದಾಗ ಇವೆರಡರ ಮಧ್ಯೆ ಎನರ್ಜಿ ಏನಾಗಿರುತ್ತೆ, ಲೆಸ್ ಎನರ್ಜಿ ಇರುತ್ತೆ, ಮೋರ್ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಇವೆರಡು ಓವರ್ಲ್ಯಾಪ್ ಆದಾಗ ಇವೆರಡರ ಮಧ್ಯೆ ಒಂದೊಂದು ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ. ಅದು ಎಸ್ ಆರ್ಬಿಟಲ್ಸ್ ಆಗಿರ್ಬೋದು, ಪಿ ಆರ್ಬಿಟಲ್ಸ್ ಆಗಿರ್ಬೋದು. ಪಿ ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ. ಆ ಆರ್ಬಿಟಲ್ಸ್ ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗಿಬಿಟ್ಟು ಹೈಡ್ರೋಜನ್ ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನೋದು ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಓಕೆ, ನಾವು ಟು ಫಾರ್ಮ್ or to overlap these two orbitals, either positive orbitals may be overlap or positive negative orbitals may be overlap, or neutral overlapping of orbitals takes place. That is learned here. Before learning the orbital overlapping, we know the types of orbitals, that is S, P, D and F orbitals. Here we are learned only the overlapping of S and P orbitals. Got it? Now we know the shapes of orbitals in the previous chapter. Now once again here we are learning or recalling the shape of S orbital is spherical. Okay, you know already this is the S orbital. Shape of S orbital is spherical and it is non-directional. Means there is no direction. ಅಂದ್ರೆ ಇದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಇಲ್ಲ, ಯಾವ ಕಡೆ ಆದ್ರೂ ಮೂವ್ ಆಗಬಹುದು. ನಾವು x y z ಅಂತ ಆಕ್ಸಿಸ್ ತಗೊಂಡ್ರೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. there is no necessity to consider x y z axis because it is in spherical in shape and the electrons density is distributed all over the atom. Then coming to the p orbitals, we can see three p orbitals. Three p orbital means the direction is different. It means the p orbital is directional. Now let's assume this is x axis. The p orbital is dumbbell shape, right? Like that. This is dumbbell, like a 8. Now this is present on x axis. That is called x orbit, that is px. Now similarly take y orbital, means this is y axis, right? We are writing vertical, this is horizontal. This orbital is present on y axis, we call py. Between these two there is a z axis, right? Let's take this is z axis. Now the orbital is present in z axis, present on z axis, that we call pz orbitals. These are three p orbitals. Now these three p orbitals and s orbital overlapping in three ways, that is positive overlapping and positive negative overlapping, then neutral overlapping or negative overlapping. Now take the first one. Now take the first case is positive overlapping. In the case of positive overlapping, positive orbital gets start to overlap. You know where the s orbital is in spherical shape and electrons are distributed all over the orbital, so that it carries positive charge. Means there is no two loops, means either it will be positive or negative. Okay, but in the p orbital, see here there is two loops. If among two, one is negative and one is positive. Similarly here, one is positive, one is negative, like that. These are the signs of orbitals. Now observe positive overlapping means plus and plus overlapping, or minus and minus overlapping. This is called positive overlapping. Now I take the s orbital, this is the s orbital, and take p orbitals, or take ss orbitals, two s orbitals, one s orbital plus another s orbital. These two get start to overlap. This is ss orbital overlapping. Okay, this is s, non-directional. Now let's take p and s. Now s orbital, this is positive, then p orbital, one is positive loop and one is negative loop, right? Now positive loop is overlapped with the p orbital. So s orbital, this is s, this is px we are taking. You can also take py also, okay, and also z, pz. This is the s and p orbital overlapping, positive overlapping. Now similarly take two px orbitals. This is ss and sp. Now take pp. This is p orbital present on x-axis, that is positive and minus negative. Now similarly take one more p orbital, that is only the x direction. This is positive and this is negative. That is positive. Let's take this is px and this is also px. Both are present on x-axis only. Okay. This is called px overlapping. We call positive overlapping of orbitals. Got it? Now similarly take another way. This is py orbital, right? Py. Now take xx completed. Now take py orbitals. The py means this is perpendicular, right? So take one py orbitals. This is py present on y-axis. Let's take this is positive loop and this is negative loop. Now take one more p orbital. See how they are overlapping. Positive means same sides are overlapping. This is positive loop and this is negative loop. Same sides is overlapping, right? This is on x-axis, this is on y-axis. That is py and py. Similarly, take z overlapping orbitals. Z means that is like that. This is on z-axis. Let's take this is positive loop, this is negative loop. And similarly, take one more z orbitals. This is positive loop, this is negative loop. This is called positive overlapping. That is pz and pz. Okay. Now coming to the negative overlapping. Negative overlapping. So in case of negative overlapping, the orbitals are overlapped with minus n to minus n. This S is spherical, so always it carries positive, not direct. Now take negative overlapping. Take the p orbital. This is p orbital. One side is minus, one side is positive. Now take one more p orbital. One is positive, one is minus. Sorry, negative. So here negative overlapping is nothing but positive negative or negative positive, not negative, not positive. Always you get here. Okay, minus adru overlap ಆಗಿರಬಹುದು, ಪ್ಲಸ್ adru overlap ಆಗಿರಬಹುದು. ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಈ ತರ ಇದೆ. ಅದೇ ರೀತಿಯನ್ನ ನಾವು ಈ ರೀತಿ ಕೂಡ ಬರೆಯಬಹುದು. Okay, also write like that. One orbital, second orbital. This is px. One is negative, one is positive. This is negative, positive. This is also px. Means negative overlapping. These both are called positive overlapping. Okay, because plus into plus only, minus into minus plus only, right? Okay, so that this is the positive overlapping and this is the negative overlapping on x-axis. This is x-axis, that is px. We are called px and px. Similarly, take y and y. This is one y orbital and this is second y orbital. This is the py, plus minus plus, like that. This is called what? Py and py overlapping. Similarly, take z orbitals. So z means we are writing like slant. Right, this is the overlapping. Now plus and minus and plus. This is called pz and pz orbitals overlapping. This is the negative overlapping of orbitals on px and py and pz. And we also can learn the overlapping of plus and minus orbitals here. Observe, this is the ss orbital overlapping. This is the s and p p orbital overlapping. One is positive, one is negative. In this case, if minus loop is overlapped here, that we call negative looping. Remember, in case of S and P, observe negative overlapping is in case of S and P, means between S and P, there is spherical in shape and positive, and P is dumbbell in shape having two loops, one is positive, one is negative. So negative and positive loop is overlapping, that is called negative overlapping. Negative loop of the p orbital is overlapped with s orbital, that we called negative overlap. This is called positive. Got it? There is plus and minus and plus is called as what? Negative overlapping. Okay. Now coming to third type of overlapping, that is called neutral overlapping. Neutral overlapping means, let's assume this is the p orbital, one is plus, one is minus. This is p orbital, right? And s is spherical in shape. So this is the overlapping of s orbital. Means a part of s orbital is overlapping with negative orbitals, and at the same time some more part of the s orbital is overlapping with positive loop of the p orbital. That is p y. This is horizontal we are writing, sorry, vertically we are writing. So that take p a, p y, and this is s orbital. This is called as a zero overlapping. Zero overlapping between s and p orbitals. Now coming to p orbital overlapping means zero overlapping place. So let's take this is in a orbital. One end is positive, one end is negative. Similarly, one more orbital, positive and negative. Both are present in py and py on py axis. So this is called y axis. Okay. If orbitals is present like that, this is called zero overlapping. Means orbitals are not overlapping. Really, orbitals is overlap agilla. ಇಲ್ಲಿ positive minus ಎರಡಕ್ಕೂ overlap ಆಗಿರೋದ್ರಿಂದ ಇದನ್ನ ಕರೀತೀವಿ zero overlapping of orbitals ಅಂತ ಕರೀತೀವಿ. Okay, this is the three types of overlapping of orbitals. Now, by overlapping of these s and p orbitals and pp orbitals, form pi bond and sigma bond in case of covalent bond. Okay, again the covalent bond is classified into two types. One is pi bond, one is sigma bond. Now we have to know how the pi bond and sigma bond is formed by overlapping these orbitals. Okay, observe or learn here. Understand, we are learning only s and p orbital overlapping. Still there d and f orbital overlapping that you learn in higher classes. Okay, now take the overlapping of s and p orbitals and forming of a sigma and pi bond concept. Now we are going to learn the types of overlapping of orbitals and the nature of bond formation. Here the orbitals are overlapping two ways. One is sideway and one more is axial way. Before knowing to the sideway and axial way, already I told you the orbitals is overlapped only they containing unpaired electrons are single electrons. Unpaired electrons is nothing but not paired. It means single electrons. The orbitals which containing single electrons only start to overlap each other and form the covalent bond. Under the covalent bond, we can study two types of bond. One is sigma bond, one is pi bond. Okay. Now here we are learning how the pi bond and sigma bond is formed and when it is formed. Okay. Now the types of overlapping of orbitals is the first one. There are two types of overlapping of orbitals. One is axial wave and one is side wave. That is axial wave overlapping of orbitals results sigma bond. sigma bond. The sigma bond is represented like that. This is the sigma symbol. So listen, axial overlapping of orbitals results what? Sigma bond. This is the first case, and second one is sideway overlapping. That is sidewise overlapping of orbitals. Results pi bond. Pi, that is the symbol, this one, pi bond. Okay, these are the two ways of overlapping of orbitals. Now take first one, axial overlapping of atomic orbitals, that is S and P orbitals, results what? Sigma bond. Now take first one, sigma bond formation. So listen, the sigma bond is formed by three ways. So how it is formed? By overlapping of S and P orbital. This is S orbital. The sigma bond is formed by three ways. One is S orbital is overlapping with the P orbital. This is take P orbital, that is pH orbital, right? The S and P orbital start to overlap, you get S orbital, and this is P orbital. This is overlapping. This overlapping results the formation of sigma bond. This is the case 1. Got it? Now case 2 means one more S orbital, P orbital, or before that take S orbital. This is case 1, or take case 2. Now case 1. S orbital is overlapped with one more S orbital. This is S and S. These two S orbitals overlap together to get S orbital and S orbital. Here overlapping. This is also result sigma bond. Now the third one is, this is P orbital. Let's take PX and one more P orbital. That is PX. So let's take one is positive, one is negative, one is positive and negative. Like that. Now it results the formation of P orbital. Overlapping of P orbitals results the formation of sigma bond. Now observe, one is positive, one is negative, and negative positive. Here negative orbitals may overlap, or negative and positive orbitals may overlap. That gives only pi sigma bond only. ಅರ್ಥ ಆಯ್ತಲ್ಲ, ಯಾವ ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲೂ ಓವರ್ಲ್ಯಾಪ್ ಆಗಿರಲಿ ಅದು ಸಿಗ್ಮಾ ಬಾಂಡ್ ಕೊಡುತ್ತೆ. These are the three cases of overlapping of orbitals and form sigma bond. In these cases the sigma bond is formed. Okay, now take the first one, SS orbital overlapping. That is SS orbital overlapping. Example to understand SS orbital overlapping, take formation of hydrogen molecule. Hydrogen molecule formation. Now you know, to form hydrogen molecule there is two atoms. They take hydrogen atom 1, its atomic number is 1. The electronic configuration is 1s1. Okay, what is the shape of S orbital? That is spherical. Right, the electronic configuration is written like that in box diagram. This is 1s1. One electron, S orbital. Okay, this is the electronic configuration we have written in box diagram. Now observe, this is the orbital. It has only one electron right there, and the opposite spin electrons only get start to overlap. This is up spin. Let's take this one. 1. Similarly, there is one more hydrogen molecule, right? That is hydrogen. Its electronic atomic number is 1 and electronic configuration is 1s1. Let's take, this is hydrogen electronic configuration in box diagrams or in orbitals. The electron, it has in down spin. Like assume one has up spin, one has down spin. Now it can also return like that, orbital, S orbital. This is 1s, so it is spherical shape. It has only one electron. The spin is downside. Okay. Between these two overlapping takes place. Where overlap results gives. So observe these two overlap. This is hydrogen molecule 1 and hydrogen atom 1 and hydrogen atom 2. Now these two start to overlap. Results. See, these two are overlap. One s orbital and second s orbitals. Between these two, what is there here? Electrons are get paired up. One is upspin and one is downspin. Are you observing here? I am writing one is upspin, one is downspin. So this overlapping results what? Sigma 1. This is the case 1. Now this is hydrogen atom 1 and hydrogen atom 2. Now between these two what? A bond is formed. This bond is called sigma bond. This is the SS overlapping of atomic orbitals and form a hydrogen molecule. Got it? This is explained by valence bond theory. This is the case 1 by the formation of sigma bond overlapping of SS orbitals. Now take in case 2, that is S and P orbital overlapping. Now case 2 B, that is S and P orbital overlapping. SP overlapping. Now to understand SP overlapping, take example hydrogen fluoride molecule formation. Okay. Now here there is two atoms, one is hydrogen and one is fluorine. Let's take the first one is hydrogen, atomic number is 1 and electronic configuration is 1s1. And write in box diagram, there is only one orbital, that is upspin or downspin. Only one electron, this is 1s1. Okay, now take the second one is fluorine. The atomic number is 9, right? And write electronic configuration 1s2 and 2s2, then 2p5. This is the electronic configuration of fluorine. Here the outermost shell is what? 2s2 and 2p. Write the electronic configuration in orbitals. This is s containing 2 electrons. 2s. Then 2p containing 3 orbitals, right? One is x direction, one is y direction and one is z direction. These are the 3 orientations of orbitals, that is p orbitals. One is take px, py and pz. Okay, now here there is 5 electrons, 1, 2, 3. This is the rules we are applying to fill the electron, that is Abbo's principle and Pauli's exclusive principle and Hund's rule of maximum multiplicity. 3 electrons, then 4th one, 5th one. Here the pz orbital is having only 1 electron, single electron. These only get start to overlap. Got it? These two are electrons paired orbitals, so they are involved in the formation of bond or overlapping of orbitals. Now this pz orbital and the s orbital get start to overlap. Now write the orbital diagram like that. Okay. Now in this case the s orbital, this one, that is spherical in shape, having only 1 electron. This is 1 electron, that is upspin. Now in the pz we are taking p orbital, that is dumbbell shape, right? Dumbbell shape. Let's assume pz. So write the axis here. This is pz axis. Let's consider this is z axis. Z ಅಂತ consider ಮಾಡ್ಕೊಳ್ಳಿ. So now horizontal ಬರ್ತಿದೀವಿ, x ಅಂತಾನೆ ಇಟ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. That is just for our convenience we are writing or saying like that. Now let us assume this is the z axis and pz. The orbital is present on z axis. Now here in z axis, in z orbital there is only 1 electron, that is down spin. One is up and one is down. You have to be right like that. Now these two start to overlap to get the s sigma bond. That is, observe how they are overlapping. S orbital and the p orbital. P orbitals. This is s and this is pz. Here the electrons are overlapping right there. One is up spin and one is down spin. This is results in the formation of what? Sigma bond. Like that, the hydrogen and fluorine make a bond. This bond we call sigma bond. Got it? This is the S and P orbital overlapping and results the formation of sigma 1. Now take the third case, that is PP orbital overlapping. PP orbital overlapping. Now in this PP orbital overlapping, to understand, you take the fluorine molecule as an example. The third case is PP orbital overlapping. PP overlapping. I hope you understand its strengths. Listen here. Now we are going to study the third case, that is PP orbital overlapping. To understand example, we are taking formation of fluorine molecule, F2 molecule, like hydrogen molecule. Now let's take there is two fluorine atoms, one fluorine atom. Its atomic number is 9 and electronic configuration is 1s2, 2s2 and 2p5. Already we are studied in the previous case. Now write the outermost electronic configuration in orbitals. 2s orbital that having 2 electrons, then 2p that containing 3 orbitals. One is px, one is py and the third one is pz. There is 5 electrons, filled electrons, 1, 2, 3, 4 and 5. The pz is vacant. This is for one fluorine atom. Similarly, there is second fluorine right there, because here there is 2 fluorines. Now this is pz orbital, take pz orbitals. One is z orbital. Let's assume this is the p orbital. P orbital, which is present on z axis. So write pz. This is one fluorine atom, right? Place. The second fluorine atom, that is also containing one electron, that is also pz. Now here there is one electron, one is upstream and one is downstream. This is one fluorine, this is second fluorine. Fluorine plus fluorine. Got it? Now these two get start to overlap. Now write overlapping diagram or overlapping of orbitals. One is s orbit. And the second orbital of another molecule of fluorine. This is one fluorine and this is second fluorine. They get to overlap. One is upspin electron, one is downspin electron. They are overlapping. So here bond form. There is sigma bond. We call it sigma bond. Okay. So this is the FF overlapping sideway. This is PZ. Okay. We are writing horizontally. It means it is present on Z axis. Okay, we are not showing the axis. If we write Z, it means the orbital is present on Z axis. This is the TT overlapping of atomic orbitals in sideway. That is, sorry, not sideway, axial way. This axial overlapping also called as, listen, this axial overlapping is also called as end-to-end overlapping. End-to-end overlapping. Or we also called as head-to-head overlapping. Head-to-head overlapping or end-to-end overlapping, or we also called as axial overlapping of atomic orbitals that results the formation of what? Sigma bond. These are the three cases of formation of sigma bond. That is SS orbital, SP orbital and PP orbitals. They overlap what? Side, that is axis. One axis alli overlap agtide, adana axial overlapping anta ಹೇಳ್ತೀವಿ end to end. ಅಂದ್ರೆ this is one end, this is second end. End ಇಂದ end ಗೆ overlap ಆಗ್ತದೆ, ಅದನ್ನ ಏನಂತ ಕರೀತೀವಿ end to end overlapping or head to head. This is one head, this is one end, or head and head and head and head, like head to head overlapping. So these are the three ways we called formation of sigma bond. Got it? Now take the PP orbital formation of pi bond by sideway overlapping of atomic orbitals. Now we are going to study sidewise overlapping of orbitals results the formation of pi bond. Already we have learned how the sigma bond is formed. The sigma bond is formed by axial overlapping or end-to-end overlapping or head-to-head overlapping of S and P orbitals or PP orbitals. We get sigma bond. Now the pi bond is formed by sidewise overlapping of atomic orbitals. Sidewise means the orbitals is overlapped like side and side. Like assume the orbital P. Now we have learned how the p orbitals is overlapped sidewise. Okay, so listen here. Let's take the orbital. This is the p orbital. Okay, let us see which is present on x-axis. Plus one more p orbital take which is present on x-axis. These are the two p orbitals present on x-axis. Now these two get start to overlap sideways. Even side by side. Head and head to head overlap ಆಗಬೇಕು. Side ಅಂದ್ರೆ ಈ head to ಈ head ಜೊತೆ side ಅಲ್ಲಿ overlap ಆಗಬೇಕು. That is called side overlapping. Now let us assume this is the one orbital and the second one is overlapping like that. Okay, so observe one orbital is overlapping here and one another orbital of an head is overlapping here. That is side by side overlapping we call as sidewise overlapping that results the formation of pi bond. This is the px. Similarly, if you take py, this is one orbital, it has a py plus one more orbital, that is take py. Means the orbital which is present on same axis, those orbitals only get start to overlap. Got it? ಒಂದೇ ಆಕ್ಸಿಸ್ ಮೇಲೆ ಇರುವಂತ ಎರಡು ಆಟಮ್ಸ್ ನ ಆರ್ಬಿಟಲ್ಸ್ ಓವರ್ಲ್ಯಾಪ್ ಆದಾಗ ನಮಗೆ ಪೈ ಬಾಂಡ್ ಅನ್ನೋದು ಫಾರ್ಮ್ ಆಗೋದು. ಓಕೆ, ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಯಿತು ಸೈಡ್ ಬೈ ಸೈಡ್ ಒಂದೇ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಗೆಟ್ ಪೈ ಬಾಂಡ್. ದಿಸ್ ಇಸ್ ಒನ್ ಆರ್ಬಿಟಲ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್. ದಿಸ್ ಇಸ್ ಒನ್ ಮೋರ್ ಹೆಡ್ by side. This results the pi bond. Okay, this pi bond we call py pi bond. This is called px pi bond. Okay, that doesn't matter here. Now to understand the sidewise overlapping of an atomic orbitals and how they form pi bond. Okay, now take example oxygen molecule. Example formation of oxygen molecule, O2 molecule. Now here there is two atoms of oxygen. Let's take one oxygen atom. Atomic number is how much? Oxygen 8. Okay, so the electronic configuration is 1s2, 2s2 and 2p4. Okay, now write the electronic configuration. Electronic configuration is, so this is the electronic configuration in orbital diagram. The s is inner shell, this 2 is outer shell. Now take s orbital that containing 2 electrons. Okay, now take p. 1, 2, 3 orbitals, right? One is px, one is py and the third one is pz. How many electrons are there? 4. Fill it. 1, 2 and 3. This is the fourth one. This is for one oxygen atom. Now similarly for second oxygen atom also same like that. No need to repeat 2 times. Okay, it is enough to write one time. Now here there is 2 vacant orbitals. So not vacant, unpaired orbitals or single electron orbitals. These 2 only participate in the formation of bond. Unpaired electrons or single electrons ಎಷ್ಟು orbitals ಇರುತ್ತೋ ಅವು ಮಾತ್ರನೇ bond formation ಆಗೋದಕ್ಕೆ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. Now write the orbitals px, py and pz. This is 3 orbitals. Let's write this is one orbital px for one oxygen molecule, and similarly for second one this is py. Then similarly take the third one is pz. This is the 3 orbitals, right? One is px, py and pz. Now see, this is only for one oxygen molecule, one oxygen atom, not molecule, one oxygen atom. Similarly for second oxygen atoms, right? Oxygen, second orbitals, and this is the third orbital. Got it? One is px, py and pz. 3 orbitals we are writing. Let us assume this is the py. This is py. Similarly here py. Okay, now let us assume this is pz. This is pz. Means same direction pz. This is py and this is take px. Okay, this is also px. ಇದೊಂದು px ಆಯ್ತು, ಇದು pz ಆಯ್ತು, ಇದು py ಆಯ್ತು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So in px there is 2 electrons paired up, right? These are not involved or participate in the bond formation. Then pz containing only 1 electrons. This is 1 electron. In one atom upstream, in another atom, in second atom downstream. This is the one more oxygen atom. Now this py orbitals containing 2 electrons. Means each orbital containing 1 electron. One is upspin, one is downspin, like that. Or you can write here upspin and here downspin. Your wish. No worries. This is the 2 oxygen atoms. Oxygen. These get start to overlap. Now observe how they are overlapping. Side by side. These two get start to overlap. Now write x orbital one. Got it? Now second one. And here third. Similarly, second one and the third one. Okay. Now this is what s orbit, that is px. Px containing 2 electrons. Here also px containing 2 electrons. And this is overlapping. This one. 1 electron, here 1 electron. These two are overlapping here inside. I am writing like 2 electrons get start to overlap. And this is what pz1. Pz containing 1 electrons. This is 1 electron. These two get start to overlap. I am writing like that. Okay. Here also you can write like that. Here, this is x, this is y, this is z. Now, these two orbitals get start to overlap, z and z, and x and x get start to overlap. Sorry, y and y. These two x orbitals are filled one. These two are unreacted, px orbitals. This is py or pz, z or y. This is py. This is pz. Got it? This is the overlapping orbitals and form pi bond. When 2 orbitals get start to overlap, one is same axis, this is called sigma bond, one is pi bond. ಎರಡು ಆರ್ಬಿಟಲ್ಸ್ ಈ ತರ ಓವರ್ಲ್ಯಾಪ್ ಆಯಿತು ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಒಂದು ಆಕ್ಸಿಜನ್ ಅಲ್ಲಿ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಇರುತ್ತೆ, ಒಂದು ಪೈ ಬಾಂಡ್ ಇರುತ್ತೆ. So you get oxygen molecule that is divalent oxygen and oxygen. Between these two, how many bonds are formed? 2 bonds. Among these two, one is sigma bond, one is pi bond. Okay, so ಇವೆರಡು 8 to 8 ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತಲ್ವಾ? ಇಲ್ಲಿ ನೋಡಿ py ಆರ್ಬಿಟಲ್ಸ್ 8 to 8 ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತು. ಇದು ಮೇಲೆ ಓವರ್ಲ್ಯಾಪ್ ಆಗಿದೆ. ಅದೇ ರೀತಿ pz ಆರ್ಬಿಟಲ್ಸ್ ನೋಡಿ z and z ಇವೆರಡು ಕೆಳಗಡೆನೇ ಈ ತರ ಓವರ್ಲ್ಯಾಪ್ ಆಗುತ್ತೆ, ಸೈಡ್ ಟು ಸೈಡ್, ಸೈಡ್ ಅಲ್ಲಿ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ಈ ತರ ತಗೊಂಡಾಗ ಇಫ್ ಯು ಟೇಕ್ 2 ಆರ್ಬಿಟಲ್ಸ್, p orbitals, this is one p orbit, one p orbit, these two are overlap side by like that, here and here, side by side overlapping, you get pi bond. If head and head like that overlapping, like one head is one head overlapping, you get sigma bond. This is one is px orbit, one is py orbit, they get to dot overlap like that, you get a sigma bond. If this orbit and this orbit get start to overlapping like that, you get a pi bond. Got it? I hope you understand, student. Like that, the pi bond is formed by overlapping side of orbitals and head to head overlapping or axial overlapping or end to end overlapping. This is a sigma bond that we are learned in oxygen molecules. Here the orbital overlapping concept and valence bond theory is completed.